Welcome to the access control of CNIT 270. Today we will continue our discussion of the different access control techniques, which is the second bullet. Compare and contrast the major types of access control policies. Yesterday we discussed the DAC, discretionary access control. We saw what are the benefits, what are the disadvantages of that type of approach. We also discussed the Unix based DAC system and what are the bit patterns, how to set them. Today we will discuss the role base RBAC, role based access control approach. So basically, role based access control is a sophisticated authorization system designed to govern system and data access by associating permissions with roles. So basically, these are the permissions over here, and the roles are in the middle. So basically, roles define the authority level here, and the permissions are authorized for specific roles over the each role will have its own set of permissions, and then accordingly users are assigned to the roles. These roles are tailored to reflect the user's hierarchical position and department within the organization structure. RBAC provides a dual layer approach. So basically, instead of directly mapping permissions or by using the access matrix as we discussed yesterday in the DAC, we have the dual layer approach here. So it provides a dual layer approach to access restrictions through data authorization and feature authorization. Data authorization grants user access to specific application features while imposing constraints on that data manipulation. Whereas it could encompass actions such as accessing, creation, deletion, and modification of the data. Similarly, the features could also be used to restrict authorization of a user to a defined set of features within that application, which can enhance the Persian control over there. So it's both way. For example, here the permissions are authorized for specific roles, and these are shown in different colors. So this role won't have the permission access over here. So basically, the in RBAC there could be constraints, there could be hierarchies. In the basic model, there are four types. We will discuss it next. That there is a basic model, and then there could be constraints of RBAC. There could be hierarchies, and then the combined model on top. So it uses the principle of the least privilege, and therefore it ensures that each user is granted only the minimum permission essential for their job function. As we discussed yesterday, the principle of least privilege basically ensures that users having the least possible privileges necessary to execute tasks such as using application, monitoring job statuses, and managing files such as creation, deletion, modification, and printing. It's next layer of the authorization as compared to the basic DAC type. So here we see that there are users, roles, and resources. So basically, the core objective is to regulate access to the resources, and as a result, organizations heavily rely on authentication and authorization mechanisms based on the login credentials. This approach, where the resources are assigned to the roles, and then users have particular roles, this minimizes the risk associated with potential malicious users, reinforcing the organization's overall security. So basically, here we see that two users are part of the role one. So user A, user B over here, and then user C is part of role two. and role 3, and similarly the user D has just the role 3. So it has many benefits. This type of approach where we define roles in a dual layer and resources are assigned to the roles and so on. For example, it can mitigate security risks through separation of duties. So because separation of the roles. It ensures a defense against potential security breaches by separation of duties or separation of roles with distinct roles. Basically, you can define constraints. We'll see some of the examples of the constraints as well in today's lecture. With these distinct roles, the impact of breach is limited, as hackers are confined to basically a specific resource assigned to compromise accounts. Therefore, separation of roles acts as a proactive defense mechanism. So the basically minimizes the risk and the scope of the threat which typically the invaders can do in a typical system over there if the system is compromised. Another benefit of this type of approach where we have roles and resources are assigned to role is the streamlining of operations and enhance efficiency. Because with the RBAC, administrators can easily manage these resources. They just need to define roles and think about the resources, which resources could be assigned to which roles. And once this whole process is done, then the assignment of users to the role become much easier. So this streamlined approach to assigning and managing access permissions allows for quick adoption to changes in the role. So basically, if there is because of the intermediate layer, remember in the access matrix yesterday we saw that it could troubleshooting could be difficult. There could be loopholes because where there are thousands of users, subjects and objects. That mapping becomes very difficult. But here in this case, since we have the intermediate layer between the subjects and objects, the layer of the roles, so therefore this become much more streamlined. The management of the access permissions and the quicker adoption to the changes in the roles and so on. So this offers a layer of flexibility which extends across diverse operating system applications, and it could also be used where the security is outsourced to the third party systems. So this is very efficient in a sense. The management, the access permission management by using this intermediate role is much easier. The another benefit of this type of approach is it facilitates compliance. It plays an important role, basically supporting organizations, companies in complying with various data protection and privacy regulations. So as we'll see, as we'll progress in this course, you will see that there are some of the control rules that must be implemented if it's a governmental organization, if it's a defense-based organization. So there are some compliance-based criteria which must be met. So these access restrictions imposed by the RBAC contribute to meeting compliance requirements, while automated role-based access reduces the likelihood of human errors that basically could expose the sensitive data in the system. So that's another benefit over here with this type of approach. It also optimizes time and resource utilization as a security. Basically, it reduces the burden on the security team, which comes with the DAC based user and permission subject and object management. It basically saves some time and enable them to focus on more high level security related tasks. So as it basically helps the system administrators in efficient management of the overall security paradigm. It also enhances visibility and oversight. RBAC provides network administrators and managers with visibility into operation and user activities because of this strict mapping. The all those actions, the strict mapping between the roles and resources, are those actions are clearly visible. Therefore, there are many benefits of these type of approaches as compared to the DSC. We discuss some of those, which are the separation of roles, streamlining of operation, enhancement of efficiency, compliance, administrative reduction in the administrative burden, enhanced visibility. So these are some of the benefits of the users assignment to the role-based approach. So we saw that here this shows the typical. We saw this type of access matrix over there in the DSC based approach as well, where there were users over there. So users, subjects, and then subjects. There were object, other resources, file system, and everything was there. So you can relate this. You can compare this type of table with the DSC based access matrix. The only difference that you see here is the roles. Instead of the y-axis over here, the column is replaced in the column. In the first column, users or subjects are replaced with the roles over there. So then that means that where will the user go? So that's the next thing. So basically, in that case, you have to have a separate matrix over there in the role-based access control, where the users could be assigned to the, for example, in this case, user 1 is part of role 1, and we see that user 3 is there. So we define a two-dimensional array over here, where in one dimension is the user dimension and the other one is the roles dimension. So basically on the cross section, intersection, we have the permissions, that whether they have permissions over for a specific role or not. So basically in this case, the roles, the top row over here can be assigned to team members or users based on their functions. What functions are their seniority level, their department. So for example, analyst, for example, if there is an analyst role over there, the role 1, let's assume that role 1 is the analyst base role over here. So in this case, analyst will have access to all the data to make the reports and find insights. However, they cannot perform any action inside the app. So basically, for example, if the R2 is the apps or the general user base, they will have the type 1 only, and they cannot do any modification in the apps. Similarly, users, the user role is to use the product to perform their core job. They perform the basic functions, but are not authorized to make organization-wide changes or access any financial details over there. So basically that's another type. Admin, billing admin, or any other type of admin can access the financial details and manage team payments and plans. However, the individuals has no visibility into any elements that can perform and tasks such as move user and other related. So basically you need to separate their function and restrict those administration job related to team management, like the timesheet app that the TAs use over here, and then also there is the HR success factors app. So they have only access to specific type of permissions over there. They cannot access bright space. So that's another example of that. Similarly, the users here won't be able to get access to the users here in the normal domain system. For example, students, staff, and faculty, they won't be able to gain access to the payment system. They will just be able to see their salary slips, and that's it. So accordingly permissions are roles are designed. So similarly, another example over there, for example, Here there could be one column for the IT team. For example, ITAB or to do the ITAB would have access to all the details of the user info, like the user ID. They will manage the authentication system, the authorization system, the topics that we are discussing in this course. They will manage groups, team settings, remote access, and the Kerberos, like Kerberos system who is using for the boiler key and all these type of systems. So they can give access, they can add new application. For example, if a new application needs a boiler ID, base login, like the two-factor authentication and so on, they should be able to register that app within the system. So these type of things are their responsibility. And then there is the super admin. They have access to all the data features and can make all the possible changes in the app. They can perform all actions that billing, admin, community manager, and development users can do. So these are the very sensitive type of. So these roles must be secured, in a sense that if any compromise occur in the super user base role, then the security of the whole system will be compromised. So these are some of the examples of the possible roles over there: IT, billing, student, staff, and so on. Next, we'll see that the RBAC 0, it's a relationship among the different RBAC models. RBAC is the 0 model where there are no role hierarchies. So basically, it's just the plane of each type of role is separate. There are RBAC 2, there are constraints, and we'll discuss the constraints in today's lecture as well. And then RBAC 3 is basically a consolidated model which builds on the top of RBAC 0, and then we have the RBAC 1 and 2, and then they combine over there. So this shows the permissions, operations on the object. So this becomes one set, and these sets are assigned to roles. And then in the roles, we see there could be a hierarchy, and then users are assigned to the sessions and the roles. So basically, that's the complete picture in terms of the role-based success model. There are some examples of the role hierarchy over there. So these are the role hierarchies. For example, the engineering department would have the engineer 1 and 2. So basically on the top we have the director. So project lead will have the production engineer and quality engineer in under the project lead 1. Similarly, 2 will have the production 2 and quality 2. And so this is how the hierarchy works. Basically on the top there is a director, so that could act as the root. You can think it as a tree where director is at the root level, and then our subsequent branches are over there. So then there is overlap. So basically that there is they could share their roles over there, they could have shared permissions over there, but in some cases there will not be any sharing. So that was about the hierarchies. It's simple, and hierarchies exist in every organization. So basically RBAC 1 is one step up as compared to RBAC 0, where they have no constraints or no hierarchies. RBAC will have the hierarchies. Next, the constraints, RBAC 2. In RBAC 2, it provides a mean of adopting RBAC to specific of the administrative and security policies. So there could be mutually exclusive roles. A user could only be assigned to one role in the set, either during a session or static. It could be, as we said, as we see in the previous diagram, that the user permissions over there here in this diagram, that it could be static user assignment, or through an intermediate layer of sessions could be created, and then for specific sessions user could have specific roles over there, and once the session is terminated, then those permissions are gone over there, which are inherent in that type of role. So next, any permission access right can be granted to only one role in that set. Cardinality set a maximum number with respect to the roles. Pre-req roles dictates that a user can only be assigned to a particular role if it is already assigned to some other specified role. So basically, the next level of for the next level role assignment, the previous level is a pre-req in that case. So in this case, to restrict the rights granted by a role to a subset of the resources, we saw that in RBAC, no hierarchies, no constraint. The basic model RBAC 1, there are just the hierarchies and no constraints. In RBAC 2, it has no hierarchies, just the constraints, which we saw on the previous slide. And then RBAC 3 is a combination of both the hierarchies and constraints. So for example, here we have the travel bucket. So there is a booking and payment. So in this booking case, we have the separate role over there. It could be dealing with the airlines booking, hotel booking, airport related services, and then the itinerary management and so on. So all these part of the booking. So there is, and then there is a separate type it's related to the payment. Payment is handled by a separate function over here. So the in this case, we see that there could be mutually exclusive roles as well, or there could be some sharing of data possible over there. So for example, the constraints could define that that some of the information, for example, in banking systems, the analyst information should be kept separate from the private banking or the public banking based user accounts and so on. So this is how the hierarchies and constraints further improve the security of the RBAC based access control systems. Next, we will discuss some of the challenges the associated with the RBAC. The role-based access controls comes with its own problems. For example, there is one interesting one is the role explosion. So role explosion is the risk of role being extensively proliferated. It's the granularity required for the access control becomes out of control. This can result in a complex matrix of the rules, making it challenging to manage and comprehend the overall system. So basically, everything gets out of hand and explode in the face of the system security administrators. That's one. Then there is the overlapping assignments are also possible in that case. Out of scope activity. And so we saw that if the since the roles are here on this, so the any error over here would lead to out of scope activity. For example, one check mark over here will give user 3 to all the permissions which are part of this role. Let's assume that there is role 3 over here. So in this case it becomes problematic and lead to out of scope activity and too much access as well. So it might not also be suitable the RBAC where there is a highly reactive approach to security. Some organizations require more dynamic and fine-grained access control mechanism that can change rapidly to a changing security posture. So in those cases where when things are changing fast, continuously evolving, RBAC might not provide the flexibility which is needed to respond quickly to the new threats and vulnerabilities. And then there could be a scaling issue as well. It may face scalability related problems, particularly in large organizations or with the complex structure. So implementing RBAC on significant scale can be very challenging if there is no IAM. Now, we discussed yesterday that IAM systems are complete tools over there, so it could become much more challenging in this case. So so these are some of the issues, some of the problems that we face in our BSc based systems. So basically, what we have discussed is that these are good because roles could be assigned. We discuss some of the benefits, we discuss some of the constraints, and we have also discussed the some of the limitations of these type of systems as well. And we also saw that if the security requirements are continuously evolving, we cannot use these type of systems.